section 10.1, let me move this down just a bit because I want to talk about greater than or inequality signs, really. This says the order of real numbers, that's fine, but really this entire section is going to be dealing, or this entire chapter is going to be dealing with inequalities and solving inequalities and graphing inequalities. And you guys are familiar with that. I just want to bring it back to you. And this first section is super simple. We just want to review some of these ideas, okay, to get us ready for solving inequalities. Okay, some easy stuff. Let's just review this. Remember, in English we read left to right. So this is called the greater than symbol because the left side, this side over here, is greater than the right side over here. Okay, so that's the greater than symbol. We can also add a line under this, meaning that this side over here can be greater than or equal to this side over here. Okay. We also have the less than symbol because this side over here is less than this side to the right. We can add a little line under there, meaning that this side over here can be less than or equal to this. Now, something to think about is we also have phrases that we use with greater than or equal to or less than or equal to. This means the greater than or equal to means at least. It's at least this much. It's greater than or equal to. Okay? So keep that in mind when you see the greater than or equal to. It means at least. Okay? This one over here is at most or no more than. Okay? Those are some phrases that mean the same thing as less than or equal to. Okay? So keep those things in mind. We're going to practice translating these words into symbols, using these symbols, okay? So if you look at example number 1 here, it says, translate the statement into symbols, all right? -3 is greater than -5. So, -3, and we use the greater than symbol, -5. Super easy, okay? Over here to the right, x is less than or equal to 8. X is less than or equal to 8. All right? Simple enough. Just keep that in our heads. All right? We're going to practice graphing these things too. So let's look at this next example. Some simple stuff here. All right. Classify each statement as true or false. Well, let's look at A. A says that -4 is less than 1, which is less than 2. Is that true? Well, you can think about it in terms of a graph as well. I mean, I know it's easiest for us to look at and say, yeah, that's true. But think about this. I know that -4, -3, -2, -1, 0, 1, 2. Right? Is that right? All right. So, when I graph these things, here's -4, here's 1, and here's 2. All in the same order, right? There we go. -4 is less than 1, less than 2. All right, so this one's true for sure. Okay. When we look at B, let's see. -4 is less than 8, which is less than 2. Well, that's not true. Okay, we can see that looking at it. I'm sorry, this is B here. Just looking at it. If we were to do it on the number line, obviously -4 goes here. Let's put 2 here. 8's got to go out there. You can see this order's been reversed here. So this is not true. It's false. Simple enough. Okay. Now, let's look at C. 7 is greater than or equal to 6. Is that true? Well, yeah. And in fact, this case, 7 is greater than 6. Okay. But the number over here to the left has to be greater than, or it can be equal to 6. So yeah, this is true. Okay. That's a true statement. And then the last one, D, I'm going to squeeze it in here. 6 is greater than or equal to 6. Okay, well the number over here can be greater than this number or equal to it. And it is equal to it. So this is true. Okay. Now, let me just throw one in here, just a little extra. Okay, down here at the bottom. 6 is greater than 6. Okay, well that's not true. That's false. okay, because it doesn't give the option of this number equaling this number, and 6 is not greater than 6, okay? All right, so simple enough there. Done. Keep moving. Let's look at example number 3 here, okay? And it says solve y plus 5 is less than or equal to 7 if, and it gives us a domain, okay? The domain is -1, 0, 1, 2, 3, 4. Those are the things that we can plug in. All right, well, let's do it for each one of them. Y plus 5 is less than or equal to 7. -1 plus 5 is less than or equal to 7. Okay? 4 is less than or equal to 7. That's true. All right, let's do the next one. Y plus 5 is less than or equal to 7. 0 plus 5 is less than or equal to 7. 5 is less than or equal to 7. That's true. Y plus 5 less than or equal to 7. 1 plus 5 is less than or equal to 7. 6 is less than or equal to 7. True. Okay. I see where this is headed. I bet you do too. Y plus 5 is less than or equal to 7. 2 plus 5 is less than or equal to 7. 7 is less than or equal to 7. And that's true, because remember, less than or equal to means at most. Okay? All right? At most it can be 7, and it is. All right, y plus 5 is less than or equal to 7. 3 plus 5 is less than or equal to 7. 8 is less than or equal to 7. Okay? No, that's not true. All right? And then our last one, y. I didn't put a check by that one. Now I'm happy. Y plus 5 is less than or equal to 7. 4 plus 5 is less than or equal to 7. 9 is less than or equal to 7. And that's not true. Now we're going to talk about solving inequalities. And we solve them the exact same way that we solve equations, but there is one difference. The difference is whenever we have to multiply or divide both sides by a negative number. When we have to do that, we flip the inequality. If it's facing this way, then we flip it and make it face that way. And we'll talk about that later. That's not a part of today's stuff. Today's stuff, just some easy, simple ideas just to get in our heads. But that's where it's headed. Okay, we could have done that here. We could have said y plus 5 is less than or equal to 7. Subtract 5 from both sides. And y has to be less than or equal to 2. Okay? So that means that this work, this work, this work. 2 is less than or equal to 2, but 3 is not, and 4 is not. Okay? But I want you to show all of that work. Just take some time. Do your exercises. It keeps you fit. Okay? All right. I think we've got one more to look at here. Okay? Now, this is a good thing for us to do because it's going to teach you how to graph inequalities all in one problem here. It says graph the solution to this inequality. X can be, or x is greater than or equal to, because I'm reading it this way, -3, but it's less than 2. All right, so when I graph this, I know that -3 is here, -2, -1, 0, 1, and 2. I'll put 1 on either side also. Okay? Now, I'm going to put a circle around the critical numbers. The critical numbers are the things on either end. So I'll put a circle around -3. I'll put a circle around 2. Okay? And we can see that x is between them. It's less than 2. So I'm going to shade on this side. Okay, but it's greater than -3, so that's shade going this way. All right? So these are all the numbers that x can be. But I need to ask myself, can it be the critical number? Excuse me, guys. Well, it certainly can be this one because it says that x is greater than or equal to -3. And you see I'm shading what x can be. So I'm going to shade in that circle because x can be -3. But it doesn't say that it can be -2. It says it's less than -2. So I'm going to shade right up to the circle but leave the circle open. Open means it cannot equal it. Closed means that it can equal it. Okay? So whenever I have an equal to sign underneath, I go ahead and color in that critical number. Okay? And that's it, guys. I think you're ready. Okay? Do a few problems tonight for homework and then let it be, and then we'll work on some stuff in class tomorrow. All right? Great job. See you later.